and our moderator, our very own Brian Mink, co-founder and president of Data Science Connect and professor at the Emory University Center for AI Learning. Before we begin, a few housekeeping items. To make this feel a little more in person, we suggest you add a photo to your profile, include your bio, LinkedIn profile, and any other information you want your fellow attendees to see. Next, please take advantage of the Q&A and chat features throughout the talk at the bottom of your screen. We always dedicate a portion at the end to Q&A, so be sure to upvote the questions you'd like the panel to address. If you're wondering where your organization stands compared to others on your AI journey, check out the poll questions in the right sidebar. And finally, to learn more about how to leverage data lakehouses in Gen AI, check out the calls to action below throughout the webinar from our sponsors, Snowflake, Matillion, Domo, and SQream. Now, without further ado, let's kick off our panel.
I'm Yaniv. I'm VP Market Strategy here at SQream on the product team. I've been in data for the past 15 years. I came to SQream through the acquisition of my company Panoply, which built a low-code data infrastructure as a service.
Welcome, Yaniv. Christy.
Hi, everyone. I'm Christy Rowley. I'm Domo's Senior Director of AI Labs. It's a research and development team, also a professional services team that helps our customers with all things AI, ML, and data science.
Super. Mark.
Hello, everybody. Mark Balkney, VP of Product Marketing here at Matillion. Matillion is a data productivity cloud for data integration and AI pipelines for low-code and no-code solutions to help you integrate all your data.
And Arun.
Thank you for the invitation, Brian. Hi, everybody. Hi, Christy, Mark, Yaniv. It's good to share the stage with you. My name is Arun Agarwal, and I lead the AI product marketing at Snowflake currently. Prior to this, I was at Salesforce, where I was leading product marketing at MuleSoft, focused on data and integration. I'm really passionate about cutting-edge technology and driving innovation within the tech industry. It's great to be here.
Excellent. Welcome to all of you, and thanks for joining us today. So today we're going to be talking about data lakehouses and generative AI. And let's just start with the basics. So many folks in our audience are familiar with concepts like data warehouses and data lakes. But data lakehouses are a newer hybrid concept that are playing an increasingly important role in data management. So can each of you just explain a bit more about what data lakehouses are for the folks who are unfamiliar in our audience, and why are they becoming increasingly important? So let's start with Arun.
Yeah, sure. So, let's take a step back and think about the data trends that's going on. And I would like to highlight 3 macro trends that we are seeing. The first is we know that the data is exploding. The amount of data is expanding, the number of sources from which we get our data is expanding, and there are many different formats of data that we are seeing. So that's one piece. The second is, how we consume all this data, and the pattern around that is also changing. From analytics all the way to Gen AI, we are consuming our data. And then the third piece is data architecture is changing as a result of all this. So we are talking about structured, semi-structured, and unstructured data, and how do we deliver the ROI, the price per performance, for various compute layers. So what I'm trying to say is we need a way to manage all of this in a unified way. So we need to think about bringing adaptability, scalability, and low cost of data lakes, and combine that with the performance, governance, and quality that we get from data warehouse. And that's where we start to think about the lakehouse concept, right? The idea of decoupling storage and compute so that we can bring the best engine for querying, transforming, running your AI models, all of that. At the end of the day, I think enterprises are looking for flexibility as they go from their raw data into large language models. And this is where the data lakehouse offers that flexibility.
Great overview. Thank you, Arun. Christy?
Sure, just to build on that, I think Arun gave an awesome explanation of what it is. I don't know how much I can add to it, but I think I can break it down a little bit. So at least in my world, the data science world, where we're doing AI and we're running models and we're doing things like that, we often historically have looked at structured data, which is stuff you can put in a spreadsheet, and unstructured data, which is stuff that doesn't fit nicely in a spreadsheet. It could be pictures or text or emails, or it could be a whole bunch of different things. And one of the things that all of our advancements have brought us to is you can bring those two types of data together and join them together, and they triangulate a lot of the findings that you have. So you can use different types of data science modeling, you can different types of AI, different types of BI skills that you use to analyze all these different sources. But when you bring them together, you can, what I like to call, triangulate your findings and triangulate really what's happening in your business, and you start creating solutions that are impactful and that matter and that are using the scale of your data in the way that it was intended to be used anyway. But data lakes facilitate a lot of that just by virtue of being able to bring together a lot of different types of data that have historically been analyzed separately.
Yeah, great points about triangulation. Yaniv?
Yeah, so just continuing on that thought, I think what Christy said is one of the main advantages of data lakehouses. The ability to put data, like different types of data, in one central repository, basically, and then do like different processing needs on that. The thing is that you could also do that in a data lake, right? What a data lakehouse enables you is basically the hybrid ability, the connection between the warehouse and the data lake, right? You have this, all of a sudden you have this management layer, you have the asset capabilities on the data lake, which basically stops the data lake, makes the data lakehouse more manageable, right? So this hybrid approach of taking the best of the data warehouse world and the best of the data lake world is designed to support this wide range, not only of data storage, but also of data processing and analytical needs in a much more flexible manner. And in this architecture, you can basically handle very large volumes of data with the ability to scale out efficiency, maintain high performance, and of both ingestion and querying, which are part of the limitations in, for instance, in the data warehousing world, right? So it's basically much more flexible, right? Both around compute and around storage. So and since you have the full asset capabilities, as I mentioned before, you basically offset some of the core pain points that you had in managing typical data lake infrastructure.
Yeah, great additional points. Mark?
Not a whole lot to add after all those. I think the real key thing too with the lake houses that haven't been overly emphasized between the rest of everybody's comments here is the point of it is to have the data in one place versus having a lake house and then replicating your data back into a data warehouse, where a lake house, the data is sitting, and as everybody has said, is separated from the compute or the workloads that you're trying to do. So you have all your data sitting mostly in raw form, and then you have that lake house and warehouse and data lake kind of structure on top of it that they've talked about, that gives you the ability to use the data in multiple workloads, but not having to duplicate it or copy it into different environments like you have in the past. If you had a separate data warehouse and a separate data science environment, and the data would constantly be replicated across all these for the different workloads. With a lake house, that data is sitting at the most bottom layer of the compute, and the different workloads, whether it's AI, BI, data warehousing, it generally will access the same data across all these different environments. So giving you hopefully a better control over your data as well. So you're not just replicating data and losing track of the data, or not understanding where data is being used because it's being replicated throughout all these different workload environments and things like that. So I think that's the only thing I could probably add on top of what everybody else has said. But I think it's important. It is a very important concept that the data in the data lake is what's feeding those different workloads, whether it's BI, AI, Gen AI, whatever it is. And you're not necessarily replicating that data over and over. So,
yeah, really great points from all of you. And I think what we're hearing here is you can combine structured and unstructured data, triangulate the findings. That data lakehouses give you a lot more flexibility around compute and storage, and there's less replication of data across different workloads. So I think that feeds very naturally into our next point, which is, what does this mean for Gen AI applications? Lots of organizations are rapidly trying to get their arms around Gen AI. They're trying to understand where do they need to be from a data maturity standpoint, from a data management standpoint, from a data infrastructure standpoint, to be able to effectively employ advanced Gen AI applications. So how did data lakehouses help them get further in that goal? And why don't we start with you, Christy?
Sure. Short and sweet this time around. There are huge advantages to having your data, whatever structure they may be in, structured, unstructured, et cetera, in one place. Especially for any Gen AI capabilities, there are big advantages to be able to have that all in one place.
Absolutely. Yaniv, what are your thoughts?
So I think it kind of builds on the answer to the last question you asked, right? So the data lake houses, they combine the best of both worlds of data lake and the warehouse, and it basically makes it easier for users to manage like access to both structured and unstructured data in one place, like Christy just said. But aside from the infinite scalability of the storage and compute, which you have on the data lake, it allows organizations flexibility to manage the Gen AI projects, as Christy mentioned. The management of these projects, like Gen AI projects, it varies, depends on the company needs, right? It depends if you're building your own LLM or if you're doing some fine tuning that requires, because for instance, fine tuning can require like gigabytes and can take weeks. But if you're building your own LLM model, that requires hundreds of terabytes to petabytes and can take months to train the model. So for fine tuning and adapting like existing pre-trained model, a data lakehouse architecture is generally the best choice, because even if you can use a plain data lake for the training, which you basically can, if the implementation requires any transaction, which it most likely will, like post the training, you're going to need all the management requirements that you have in the lakehouse. And I don't think there's basically any reason to discuss warehousing technologies for this kind of use, because the data lakehouse basically has all the advantages of overtaking like previous lakehouse technologies. But traditional warehousing basically requires, maybe there's like one small thing to mention just before I finish. Traditional warehousing that requires schema on write is usually not what you would like when you're fine tuning a model, which usually requires schema on read, because you're dealing with raw data and you're dealing with a lot of data and you want to do a lot of different permutations. So the speed of ingestion is important for LLMs, right? It's not necessarily important for fine tuning, but a lakehouse and a data lake can also deal with unstructured data, and typical warehousing did not really need to, or are not really cannot really handle that type of data. So that's those are my points.
Yeah, Mark.
Yeah. So I think with unstructured data and structured data, that's where the lakehouse and data lakes, traditionally data lakes could always handle that unstructured data, but lakehouses give you the ability to really open the door to more people in the organization to access that unstructured data, right? So I think that's what we're seeing a lot with more traditional data warehousing people and customers that haven't always had access to that unstructured data and LLMs or generative AI to do things with that unstructured data, making it easier for them through the lakehouse, easier because they have access to this data quicker and easier, is really opening the doors to a lot of new use cases, as well as we're seeing some use cases that would have been traditionally harder because it was really required your data scientist team or a really highly skilled data scientist to take action on unstructured data, where generative AI gives them a little bit easier, less not having to know as much about data science to build out some of these use cases, right? So that's where I think the intersection of generative AI and lakehouses are opening the doors to a lot more people a lot more users to do things that they haven't been able to do in the past.
Yeah, great point there about data democratization and how the role that data lakehouses can play in that as well. Arun, what are your thoughts?
I mean, these are such great points. Just to build on this, I think of it in terms of the journey that your data needs to go from raw format into your large language model, right? So all of us are familiar with the ETL framework. You may have to prepare your data, extract your data, and consolidate it from different sources. So you need an engine here. Then you might need to do some type of data engineering to separate signal from noise. So things like data cleaning, traditional pre-processing, transformation, those types of things. And you may need an engine for that. Then you might also be doing some predictive work. You need an engine for that. You need to manage and store and transform your data, optimize and store it. You may need an engine for that. And then you need to bring all of that into your generative side. So you also need to think about how do you process your data within the large language model. And all of these things need to be done to build your AI application. So the question here is, how do I keep lineage of my data so that I know information throughout this pipeline of what's happening to my data? And I need that flexibility, right? So by having a data lakehouse, you have that unified platform that you can use to manage and keep track of all types of data that you're using for your models, right? So people always think about, how do I streamline my entire generative AI ML workflow? How do I get accurate responses? How do I stop models from hallucinating? How do we build a robust system that's governed, secure, monitored, and can be trusted? So we often talk about, at Snowflake, we talk about how do we bring AI to your data versus taking your data to the model. And there's that nuance of how do we think about responsible AI. And this is where having a unified, flexible platform like Data Lakehouse can be really impactful.
Yeah, absolutely. Those are excellent points, all of you. So one question I think a lot of folks will have if they don't currently use a data lakehouse, or if they're only using it for certain aspects of their data and are not using it across their entire organization, I think the question is going to be, what are going to be the biggest technical challenges, and what are the change management challenges in terms of migrating their data over, in terms of starting to use a data lakehouse? Obviously, if you're launching this for the first time as an organization and you have lots and lots of data, this can seem like a very daunting task and a very heavy lift. So what recommendations would you make in that context? What are the issues that folks are likely to face? Let's start with you, Mark, this time.
Excellent. I can go first. So I think one of the biggest challenges is interoperability of the data itself, and where the data is physically stored. So I think what you'll find, and we've talked a lot about the different workloads, whether it's Gen AI and training models, or data warehousing and just building out schemas, things like that. What users will find is their lakehouse could be, or their data lake could be built on S3, or it could be on Azure, or it could be on everything. It could be on all the major clouds. Their data could be stored across all of those. And then the data is going to sit in different formats. It could be Parquet, it could be JSON, CSV, who knows? It could be all types of different formats, unstructured data as well, and image and things like that. And the issue is not all the different engines that Arun was talking about, or others have been talking about, will work on that type of data. And so that's where I get excited about watching the progress of things like the Iceberg, people adopting Iceberg, which is a standard format of data across storage layers, and being able to access it with different engines, different compute engines and things like that, like Snowflake, who's on the call with us today, and be able to access those things. So I think the biggest thing people should think about as they embark on this is where and how should they store their data, in what formats, in order for these different engines, compute engines and workloads to work across them, and make sure that they have that interoperability, so that 3 months or 6 months or a year from now, you're not going back and saying, oh man, I gotta reformat data, I gotta move data around or change data because I want to use this engine now versus that engine to do XYZ workloads. So I think really thinking about that interoperability, look at things like Iceberg or Delta Lake or whatever standard, pick a standard. I think they're going to kind of come together eventually, but I think that's one of the top things that people should really start thinking about if they are just starting to kind of embark on that data lake and lakehouse journey. So,
yeah, great points. Yaniv?
Yeah, so I'm going to touch on a couple of points. One of the points that Arun made in his answer to the previous question, and some of the points that Mark made. So I think that the biggest challenge in implementation of any new architecture, regardless of what that architecture is the migration of the data while ensuring the quality of the data. So I think the most important thing to remember while doing the migration is that it's not a one-off thing, right? So once data is migrated and schema is set and all tools and queries are running, data migration or data movement will continue to be a thing in the new architecture, especially in data lake architecture, because you got to move the data all the time between databases. And a data lakehouse is basically what you make of it, right? Because you're building it on the basically raw bones of the infrastructure. But capabilities like time travel and schema evolution, which are basically enabled in Iceberg and Delta Lake, are critical for the management of the workflows. So I think that it's super important that when you build this new architecture, that you use ETL and workflow tools that on the one hand serve your one-off needs, but then also serve your ongoing needs. For example, if you're looking to build infrastructure that requires training like LLM models on the infrastructure itself, meaning you need to process hundreds of terabytes that need to be processed and moved between databases in your lakehouse, then using strong GPU-based workflow management tools like what we do here at SQream are required. But if you're looking at smaller data samples with transformation history and lineage, then tools like DBT or Matillion may be a better tool. So regardless of what you use, I think that when it comes to data migration or workflow management, governance, cataloging, things like that, I think all of them are really good investments that are better bought off the shelf than built from scratch.
Yeah, really great points. Arun?
I mean, yeah, these are great points. Let me take a slightly different approach. I always think about projects in terms of PPT, so people, process, and technology. We talked a lot about the technical challenges, the data governance that Yaniv talked about, the compute engines that Mark was talking about. From my perspective, I'm going to make it a little bit more tangible. So in terms of process, the question is, if I'm thinking about moving all my data into a single place, well, that sounds like a crazy project. So how do I scope it? How do I build the right checkpoints? How do I do some type of POC so that I can get a clear understanding of what the project is and how I'm going to see the ROI would be one piece. And then from a people perspective, I'm bringing all this data together, but there's a goal behind it. And the goal is, how do I enable different types of users in my enterprise to make use of this data and take some action, right? So I may have users who are no-code users. So how do I make data accessible to them? Some of them may be SQL and Python users. So maybe using some type of REST API-oriented solution would be a better option there. And now we are introducing this whole idea of generative AI, which is super exciting because now we can also think about an entirely new type of interface, the natural language interface. So how do we think about the chat interface layer and how do we bring that into our data so that we can start to take immediate actions, time to market, and differentiate ourselves? And to answer the second part of your question, you were asking how are organizations handling these challenges from a process perspective. I would suggest let's pick a project, maybe a small project with defined scope. We can understand the ROI of this project, maybe a marketing project, because usually that's where we start. You start thinking about how do we bring some of the data that's relevant for this project, and then we bring some more data and some more data. And over time, once we have proved the value, we can then start to scale. So that's the process piece. And from a people perspective, I would say for enterprises, we can start to think about building center of excellence, right? This is where we would have a list of best practices, what are the right processes, so that different teams can start onboarding versus doing their independent learning and growth, which can be fragmented and also inefficient.
Yeah, great points about the center of excellence. Chrissy?
Yeah, I love all the points that everybody's made. They're really valid and really valuable. I'll build on what Arun said a little bit too, and I'll take a very data science approach. So I'll be the data scientist in the room. And maybe I'll even give you too much insight into my own self. So I have a junk drawer. It's right next to my refrigerator. Like everything goes in it. Like I get a little piece of something, go, I know I can use that sometime. Put it in the junk drawer. Every time I've seen people migrate data into, have all your data all in one place, sort of a strategy, you end up with a junk drawer. And sometimes it's a little bigger than a drawer. It might be a whole room. And it's so easy to just put stuff in the data lakehouse or whatever, just because it's there. You don't know what you're going to do with it. You don't know why you have it. It might come and you might use it at some point, but that is a really, really difficult mess to clean up. So I would counsel people to not make more messes while you're anxious to adopt new technology. Be really specific about what you want to do. And to that point, I'm a firm believer that the most important resources that any company has is their products, their people, and their data. And any more data is a commodity, and it's something that you can buy, sell, and trade. It's something that's richly insightful. It's something that you can run your business on. So be really directive and programmatic about how you incorporate data into a lakehouse situation so that it's useful. You don't end up with junk drawers, and you end up with a strategy, and you don't have to do it all at once. You don't have to boil the ocean. You can do this one project at a time and make it a project that's really meaningful.
Yeah, great points. And I think the junk drawer tees up really nicely for our next question, which is about performance and cost efficiency. So what opportunities do you see with data lakehouses for improving performance and cost efficiency? I think if you've got a junk drawer or a junk room, you're definitely hurting potentially your performance and cost efficiency. So what opportunities are there, but also and what potential pitfalls are there once you have this data lakehouse? How do you make sure that it doesn't become your junk drawer, and that that you are able to maintain the types of performance and cost efficiency that you set out to attain when you made this investment? So let's start with you, Yaniv.
All right, so I'm a bit biased here because everything about what we do at SQream is around performance and cost efficiency in extreme use cases of analytical data. So I'm going to talk specifically about that. So I think today we're living in an age of influx in GPU. So currently GPUs in the four largest cloud providers are underutilized, and that's by their own admission. So GCP, AWS, they discussed periods of underutilization due to workload variability. So they're all working on dynamic resource allocation, which is great. And during this process, there are like new GPU clouds that are emerging specifically for these needs because of the whole Gen AI hype, which basically means, at least from my perspective, is that I think that GPU processing power and prices are going to become more and more of a commodity. So I'd make sure when building my lakehouse, even though GPUs today are on a one-to-one comparison more expensive, I think that in the very near future, that's not going to be the case, and they're much more powerful. So I'd make sure that my lakehouse is built in a way that can harness analytical and transactional processing on GPUs as well as CPUs. I think that running your SQL and Spark on GPUs is going to become more and more common in the very near future.
Yeah, great points. Mark, you want to take next?
Yeah, absolutely. I'm going to piggyback on Christy's comment. She didn't use the word governance in there, but really it's all about the governance of your environments, your lakehouse, your data, and that's super important. I just want to ring home what Christy was saying about the junk drawer, and don't repeat what happened in the Hadoop days with the data lakes back in the Hadoop days, and where we just threw all the data we could. Like, if you're starting out, you should start out with data governance in there, have data literacy, understand where data is coming from, the lineage of the data, how important is the data still being used. Don't move data in that's never used anymore. There's a whole area around data observability too, and vendors around that space that really help you do that, and have some pretty amazing stories about being able to clean up data that's terabytes of data that's just sitting in data lakes that nobody uses anymore. And that dramatically, one, improves performance as well as reduces cost. So have good governance around your data, because it's ultimately going to help as well with the performance as well as cost in your environments. If your processes are scanning terabytes of data that's never used anymore because some data engineer or data scientist does a select star across all the environment, all the data, God forbid they do that, but it's going to cost time, money, CPUs, GPUs, all that, versus if you are very diligent about and having good governance about your data lakes, which if you're building a new data lake and data lakehouse, then do it with governance from the get-go, and help you in the long run for sure. So I think having good understanding, good literacy, and good governance of your data and your environment, and what you do or don't use or need anymore. Keep that in mind as you're building out these environments. That will ultimately help with your cost as well as performance in many cases. So,
yeah, great points. Establishing that governance framework up front. Chrissy, your thoughts?
So I don't know if I have anything to add, Mark. You stole my governance story there.
Sorry.
Yeah. No, I love it. I love it. A lot of the things as a data scientist, again, when you start navigating away from more of your traditional analytics and BI, and you start getting into more complicated data structures and data solutioning, it's really important to maintain the integrity of all those data sources. And so it's really useful to join what Arun said earlier about a center of excellence, and what Mark is talking about data governance, so that you've got a lot of people on the panel that's deciding how to incorporate data and how you store it and how it looks and how you're going to let people access it, things like that. Because there's a lot of different ways to use data, and we don't expect any one person to get it right all the time. But a center of excellence with a lot of voices who can help the whole business understand the value of the data and what to do with it is really useful and helpful.
Absolutely. Arun?
Yeah, not much to add here. I feel like the way I think about it is more from a system perspective, and how do we think about integrated architecture. So, the panel talked about various things. I think of it in addition to all of that, as these large language models get even larger, how do you reduce the movement of your data for latency purposes and also for security reasons? So just to add to what folks were talking about, having that unified monitoring capability is going to be really important. I should be able to control my data agnostic of the vendor and the engine. I should not need any special tooling. I should not be needing any proprietary formats. And I should be able to use my data without making copies, like Mark mentioned earlier. So in my mind, the data lineage and control is extremely important, and it's going to continue to become more and more important. So just in addition to all the cost and governance perspective, also keep in mind how you think about your lineage and track that.
Yeah, great point. So now I want everybody to kind of take a look into the crystal ball, and we're going to make some predictions about where we see this landscape evolving. We've talked about data lakehouses are a relatively new innovation. Obviously, Gen AI, lots of hype right now, and lots of organizations thinking about how they need to be able to leverage Gen AI moving forward, and other types of AI. So what are your predictions for how this landscape is going to shake out? How do you see things evolving, whether it's data lineage or whether it's data literacy? Like what are going to be some major trends that we see emerge in light of innovations around data lakehouses and Gen AI? Why don't we start with you, Chrissy?
Oh, great. I'm excited for this one. So the data scientist in me has been waiting for this day for 30 years. Like, I think we're all going to start thinking about data like data scientists think about data. I think we're going to start thinking about data cleanliness and data readiness in all of the ways that data scientists have been doing it for years, because that is how Gen AI and chatbots and those sorts of things are going to get context. That's how they're going to understand data. That's how they're going to join both structured and unstructured data, is by having really, really clean, well-defined, well-described data sources, data sets, data columns, and data dictionaries.
Great point. Arun?
Yeah, absolutely. So I think of it in terms of two aspects: performance and ethics. So from a performance perspective, like Yaniv was saying earlier, introducing more GPU-based compute has become part of Gen AI. Previously, we were using GPUs only for training, but now it's necessary for almost everything. From inferences to generating text and images, we are using GPUs everywhere. So how do we manage performance and enhance that would be one aspect. And then the other aspect is going to be the trust and ethics piece. We are moving to a world where we are asking questions about our model outputs. How are these models trained? How are they giving the answers that they are giving? And how reliable are they, especially when it comes to enterprise grade AI? So this is where cataloging and having information about your data via a semantic layer is going to be crucial. At Snowflake, we just announced a couple of new features, Horizon and Polaris. Mark alluded to it earlier. All of that with the goal of bringing that cataloging and information in one piece. So I think in my mind, having that source of truth well documented and scrutinized and regulated within AI is going to be really, really important.
Yeah, great point. Mark?
Sorry, cut out. I didn't know if you said wait. So yeah, I mean, for me, I think in the crystal ball is we're really going towards more of a kind of a composable architecture to really meet the needs of all the different requirements. I don't think Gen AI is going to replace your traditional BI reporting. I don't. I maybe I'm wrong, but hopefully people aren't using Gen AI to determine their revenues and things like that quite yet. So, because you'd hate for it to hallucinate and tell you you're like tripled your revenues or something like that. So, I think a composable architecture to be able to plug in and kind of plug and play the different workloads that you need, have the right understanding of your data, where the governance comes into play, and things like that, and be able to control your data debt, but be able to understand how you need to build the models, and have the right context on your models for generative AI while you're still doing your traditional AI and BI type activities. So I think going towards an environment or architectures where it is more composable. If you need to train a model, you can plug in Stream, or you can plug in something from Snowflake to be able to make that happen very quickly on your data. And I think governance is a key part of that. I think the interoperability of the data, the way it's stored, is also very key to that, and the governance across the board. So I see, I see the future. I hope we become much more, composable type architectures and interoperability kind of plug and play for what the businesses need, what the users need at the right time, without having to go out and purchase a whole new stack and move data and do all this other stuff. Hopefully, we can just get to a point where you plug in the right vendor for the right process at the right time. So we'll see.
Yeah,
maybe hopeful dreaming.
No, great points. And I mean, there's so many great solutions out there to solve a lot of the issues that organizations are having. So you hate to see something like just integration be a barrier to that when the right solution is there. It's just a matter of being able to plug it in. Kind of.
Yeah, so I don't think I can comment on where like Gen AI is going to take us. I think it's a much larger revolution than we can imagine right now. Basically, from a philosophical perspective, it takes us from a world of ones and zeros to a world of probability, which is I think is enormous in terms of the way we can perceive everything we do around computation in the future. But I will touch what I think is going to happen on the infrastructure level. And basically, I think we mentioned this a bit in the earlier answers. I think that once ACID becomes more frequently used and easier to implement in the lakehouse, then data warehousing is basically going to be a thing of the past. It has like no real advantages anymore. And we'll see the data lakehouse as the new infinitely scalable infrastructure, both from storage and compute perspective. And inside that infrastructure, at least from what I'm seeing right now and my perspective, I think the core capabilities around the management of that infrastructure are going to be around the management of the data workflows. I think that's going to be the most critical point that's going to make or break your data lakehouse.
Yeah, great points. Before we get to our lightning round, I want to jump to a few questions that we're seeing over in the chat. So Michael O'Connor has a great question. When will the hype around Gen AI come back down to reality? Right now, many think that it's going to solve all problems / purposes that a business has. When will it be widely realized that Gen AI will only be applicable to certain use cases? And what are the most likely high impact use cases? So who wants to take that one to start?
Oh, I'll go. Please, can we end the hype today? Pretty please. Like, I'm so done with it. And while I'm done with the hype, I do think that what the hype has done is it's shown a spotlight so brightly on what's possible with data. I agree. I don't think Gen AI is going to answer all of the business questions. I don't even think it's going to answer the most important business questions. But what it does is it shows what you can do with math, and that's cool. So it's absolutely magical. It's not magic, it's math, but it's absolutely magical of what it's done and the attention that it's raised around data. I think what we can do with that to really harness it and move it forward is to really think about what data we've got and what we want to do with it. And let's start talking to people about what we're going to do with these data. Like, how can we revolutionize our business with the data that we have? And how can we get even better data in the future to answer the questions that we have? I don't know that there's any one use case that is universally important. Every business is run differently, and every business needs to ask their questions within the context of their business. But there's so many cool things we can do with data, and I hope that idea never goes away.
Great points. Did anyone else want to weigh in on that one?
I can maybe touch it just a bit, just because I don't think it's a hype. I mean, yeah, I mean, Gen AI is not going to solve all our problems, like Christy said, and it's probably not going to solve our most important problems. But I think it's the way we approach problems is going to change, because we don't live in a deterministic world. Like in real life, and in computer science we do, but in Gen AI we don't. We live in a probabilistic world, meaning a world of probability. And if we start solving problems thinking about it like statisticians and not like mathematicians, I think that's a whole new vector of thought in computer science. I think it's remarkable. I think it's going to change everything.
Yeah, really great perspective. Arun and Mark, any thoughts there?
Yeah, you threw in probabilistic, deterministic, vector. I can't think you got them all, man. Great job. I think I like the hype personally, because I think it's really opening, it's bringing data back to the forefront at the C level, at the very high level of organizations. And it's giving everybody in the data community a great opportunity to jump on the ability to really look at how can you solve problems that maybe you hadn't been able to solve before, right? And I think taking the fresh approach of, deterministic versus the probabilistic is a great way to start thinking about problems differently. But the hype is really giving everybody the opportunity because the C level and the senior levels are pushing down on, hey, what can we do with this? It's really bringing data and solving problems back to the, making it cool and very important again. So I think it's an opportunity for everybody in the business to really jump in and take advantage of this time. And that's what the hype is really giving, I think, the data community within organizations kind of a forefront, bringing them back up to the C level, really. So,
yeah, absolutely. Arun, anything to add there?
I mean, these are all great points. Maybe I will just touch up on the specific question around use cases. There are several dozen use cases that enterprises are thinking about. We are seeing a lot of use cases around batch text processing. This is where you would think about how do you summarize large text batches? How do you think about sentiment analysis, translation, those types of things if you're a global company. The second one is around business intelligence. So this is where Yaniv was talking about how do we use analytics and SQL to kind of get answers quickly from the repo of data that you have. And then the third one, I think Christy touched upon this, is document assistant. How do you answer questions about internal documents, wikis, FAQs, those types of things? We are seeing a lot of positive results in these three use cases.
Yeah, great points. There's another question kind of building off of that, Arun. Eric, I believe, in the chat asked for specific use cases and was specifically asking about business cases that leverage techniques such as RAG, retrieval augmented generation, fine tuning, and text to SQL. So wondering if any of you have any good examples of or successful use cases around that, or case studies where we hear a lot about these techniques in the context of LLMs and being able to effectively leverage Gen AI. So if you've seen anything, if you've seen any great use cases there that organizations work for.
Yeah, I mean, enterprises are, starting to implement these things. To Mark's point, a lot of them are not in production yet. There's being a lot of tests done to make sure it has binary 0-1 output so that we can trust all of these things. From our perspective, we are seeing that, some of these large models can be quite expensive to run. You may be able to get very similar results if you fine tune a smaller model and run that. So that's where the fine tuning aspect comes in. And for RAG, we are seeing that if you want to minimize hallucination and get more relevant information, then you can prompt your model and augment it with more of the internal wiki, the information that you have specifically, which is very rich. And that can help you become more efficient and differentiate yourself in the market.
Great points. Any of you others seen any good use cases around those?
I can chime in.
Christy?
Oh, sorry, Mark. I'll go, and then you. At Domo, we use a lot of data. We bring data into the Domo platform. We transform it. We do data science on it. We do all kinds of things. And one of the great things about things like text to SQL, and it could be text to Python or text to whatever, it just allows people who might not have any formal training in a lot of different data languages to utilize it, and utilize it really effectively. It's remarkable at how well that particular use case works. And I love the idea of making data more accessible and so it's not hiding behind tools and your ability to use them. It democratizes data in a way that's really powerful. So I think that's a powerful use case. I love seeing it. We've had a lot of success with that at Domo.
Yeah, Mark.
Yeah, so we've had a use case of helping customer support. So using training and fine-tuning a model around the user documentation and knowledge-based articles, and then being able to take cases coming in through Salesforce, the service, our module of Salesforce, and running against the model and building out an auto response so that when the customer support people come in and look at the ticket, it's not just looking at it and then having to go do the research. The large language model has already generated a response so that the customer success person only has to review that response and make sure the links to the knowledge base articles or to the user documentation is accurate and correct to help actually answer those questions. So for that customer, we have greatly reduced the amount of time that the customer success people spend on responding to tickets, because now they're just reviewing the response. And maybe, I think it's the last time we went through the RAG process and understanding and fine tuning, it was about 60% of the emails never had to be touched. They were good. They could just hit send because they did address the answer or the questions and the problems. And then another 20% of that had to be slightly modified or additions added to it to help answer those questions. And then the remainder were maybe hallucinations or just didn't have the right answers because the documentation or the content wasn't there. Back to the importance of your actual data and giving the models context, right? So, using it in that kind of, using generative AI in that use case was very helpful in giving the customer a lot more productivity in the customer success team to be able to address and answer questions faster and be able to keep customers happy quicker and ultimately affecting the life of the customer at our customer using this type of technology in the pipeline. So hopefully that helped address or answer one of the questions. So
yeah, great examples. Anything else to add, Yaniv?
Nothing too much, but just very generally, we've also had success in the text-to-text, meaning in the documentation, summarization, and search in text. But that's, I think, a kind of pretty obvious use case for Gen AI. I think where we've been looking but haven't had real success is the text-to-SQL, or generally speaking, text-to-code. Off-the-shelf solutions are not there, at least not something that you can count on. And I haven't seen any fine-tuned model that does it in a very good way. I'm sure it will come. I'm going to check out Domo very soon, but I'm sure something off the shelf will come pretty soon. But we haven't had any like fantastic success with text to SQL or text to code.
Yeah, great points, everyone. So now we're going to wrap up. We've got a few minutes left, so we're going to wrap up with our lightning round. So in one phrase or a few, if each of you could share one critical insight or takeaway about the future of data lakehouses in the context of Gen AI. Why don't we start with you, Arun?
Yeah, so I think building consumer-grade AI is not the same thing as building enterprise-grade AI. Businesses want AI to be easy, efficient, and trustworthy. And those are the three things we are focusing at Snowflake, and those are the three things we should think about in context of data lakehouse and Gen AI.
Great. Yaniv?
Yeah, so I think, as I mentioned before, GPU will become a commodity. So don't be afraid to experiment with SQL and Spark on GPU.
Mark?
I think Lakehouse and Gen AI together really unlock the art of the possible. So if you didn't think you could do it before, think again and see if you can try to make it work and get some smart people in the room, and I bet you can make it happen. So give it a shot.
Absolutely. And Christy, we'll give you the last word.
All right. My last word, data is a commodity. It's incredibly valuable. It's worth investing in. But the way you store it, the way you use it, the way you catalog it, and the way that you interact with it is the most important piece. So focus on that when you're doing or adapting any technology related to data.
Absolutely. Great points, everyone. Thank you very much to all of you for joining us for a great discussion today. For our audience, if you missed any of the webinar or want to rewatch anything, the recording of this webinar will be available right after. If you just refresh this page, you can watch it. It will be available. We'll also have an edited version up on our YouTube channel later this week. Want to give special thanks again to our partners at Snowflake, Matillion, Domo, and SQream for making this webinar possible. Thank you all again for joining us. We look forward to seeing you next time. Thank you.